Today we're going to go ahead and talk about zero trust in the government. And we're going to take it pretty basic. We're going to talk about what is zero trust, how it fits into the government scenarios, some of the core principles, strategies, and some of the challenges, and some recommendations. I'm Steve Taylor. I'm the CTO of DeployHub. We specialize in the DevSecOps arena. So you'll see a lot of this is tailored to your development practices versus securing a runtime environment at that level. I am on the TOC for the CD Foundation, which is under the Linux Foundation here, and I'm one of the chief architects and contributors for the Ortiz project, which is underneath the CD Foundation. So what is zero trust? One of the things that we talk about zero trust is you never trust anybody, but you always verify. What we run into is we do get breaches, and it's really bad when we get a breach, but what we want to do is minimize how that can occur, whether the breach is going to be coming in from an external source or if it's going to be internal. You get a bad actor from the internal side of things, disgruntled employee. In order to deal with zero trust, you always have to continuously validate. And you'll see this in some of the slides. It's like verify, 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 verify. You'll get tired of hearing me say verify, guaranteed. You want to look at the user side of things, but not only and that gets into MFA, least privileges, that type of stuff. Also, on the device side, device is really generic here. It could be, my laptop as a device, a router, or your cloud instances. Dealing with separation of networks and stuff like that on AWS for example. And then also down at the application level, how are changes getting from the developer out to your production runtime environments? We want to make sure that process is as secure as possible, but not only secure, but can we verify that it is secure as part of our goal here. So one of the key principles that you'll see when we start talking about zero trust is really trying to segment things out, because what you want to do is prevent jumps. I can go from a green network and then get through a server onto the yellow network. We want to avoid that. So we want to have the segmentation in place to prevent that. Also, we want to know who people are at that level. So if I want to get onto a green network, I'll have one credential and I'll have a separate credential for the yellow or high side at that level. So I don't want to reuse credentials across those different systems. So we'll really get down to doing this segmentation, and we really want to drive into really small defined roles. I'm currently working on a contract for Los Alamos, and I was looking at some of the privileges for one of our GitLab runners, and I was impressed that they went through and listed every single individual privilege instead of just going star, make it run. Even though it's on the commercial green side, I want to make sure that it's secured, because that will, if I open something up there by accident, I can let somebody transition through to a higher network. And then we continuously verify. If you can't continuously verify, audit. You actually end up getting stuck auditing all the time as well. Then there's different things you do with those audit logs. It could all get funneled into one place, so disperse logs especially around logins, logoffs, those type of things, access permissions, guard duty findings from AWS, all that will get dumped out into different log groups, but that should be interrogated and filtered and then pushed up so you can get alerts, make things happen more automatically at that level. So you want to take this big, huge, all this log data and push it in through where it's going to be usable and queryable. So why are we talking now about zero trust for the government? How many of you are DoD, DOE? One, two, couple, handful? Yeah. So you've run into some of the executive orders, 14028, having to deal with zero trust. That executive order really kind of got the gears moving. I wouldn't say it's the end of everything. I just was talking to yesterday the gentleman, I don't know if he's here, I can't see him. He wrote the NIST requirements and also helped write 14028. He said there's a new revision coming. It's been somewhat approved, but look for that. So one of the big changes in the new revision he was telling you about was the self-attestation part has been removed. So in the original 1428, you had to do self-attestation. That's been removed under the new administration in the update. So that will change a little bit of things. It's not quite public yet, but it's coming, just to give you a heads up on that front. Also, when we talk about zero trust, we really look at the increased number of cyber threats. Anybody guess how many threats will be reported today into the CVE database? All right. 600? 2,600? A little bit lower for one day. Not for one day. A little bit lower. It's about 150 confirmed CVEs will be reported today. How many, since we've been tracking CVEs, how many think we've found so far? We started tracking, I think, in the 90s. So anybody quick at math? We're doing 150 a day for the last 20 years. It's pretty close. It's the last time I checked, it was 267,000 that are out there, and that's a good number of threats that are out there. Some of the research is pointing to that doubling within a year. So just because of AI technology, those type of things, a lot more bad actors out there, we're going to actually increase that number of vulnerabilities out there. There's one I just saw the other day where I believe, I can't remember, I think it was GitHub identified like 80 new repos that are named really nice. Like this is my Splunk logging utility, and it's a Python program to help you deal with your Splunk logs. Well, that is 100% malicious code and ransomware. They have a bunch of those that are popping up a lot. GitHub's been going through and trying to close those repos down. But that's becoming more and more common, is throwing these libraries out there that developers don't really get a deep dive into, and they start consuming this code, and then all of a sudden you got a worm going through the network just by accident. And then also what we're seeing is a lot more work on the cloud. The AWS Gov Cloud. The other day, Microsoft announced the Azure Sovereign Nation, great name, isn't it, for the EU. So the EU wants to have its own everything and be able to control everything and not to be dependent upon the United States. But they're still dependent upon Microsoft, so I don't get the logic behind it. But that's coming, so there's these new type of networks that are showing up out there that you have to be aware of. Other things, which is always interesting, how do you have researchers, like at the DOE, how do you have researchers that come in from other countries that need to work on, I wouldn't say classified projects, but are projects that are, do have some CUI data in it? How do you address them? What's their role? How do they have their access? And this gets back to that microsegmentation. What access do non-US citizens get? Do they get free range of a project, or do you really tighten them down? How do you report upon them? So that's something that you have to consider as well. $9.5 trillion it costs us. So that's not only in the remediation costs, but also the cost to lost business. So if you look at Southwest Airlines or Delta, some of those outages that they run into because of software problems, it's a huge cost to them. Currently, based on the research, half of them are being targeted directly to government agencies. Oh, this is a good one. I should have quizzed you on this one. So, and this is going to get worse. So what this graph is showing is the typical time in the government to remediate an issue is over 100 days. And the exploit is actually happening in less days. Yes, you have a question. I'd have to look at the IBM down here. There's going to be an IBM link. I don't know. Tracy, do you remember if that was critical or high?
Pretty much for specifically for data breaches.
In general, it was a data breach. They didn't get into, I don't think they got into low, medium, high critical vulnerabilities. This is going to get worse. With the bad actors being able to use AI to generate their exploits. I've heard that as quick as 12 hours. So when you get a new CVE posted out there or something that they like, they can start exploiting it and going after it in less than 12 hours. So we do have our work ahead of us to close this down. So some of the core principles that we're going to talk about is, like I said, verify and authenticate as much as you can. Definitely use least privileges access. I know this one's a headache. It totally is a bummer when you got to deal with it. You got to go, you want to get something done. You're like, all right, I got to get this report done, but I don't have access to it. It'd be a lot easier if I could just, bump up my privileges and get the report done. But you really have to put in place least privilege access. And when you look at the CI/CD pipeline, you even segment that out into privilege levels. So the developer, when the developer checks in their code and they're going to do a merge request, that merge request is going to run on an ephemeral build engine, for lack of a better word, ephemeral runner, and that ephemeral runner is going to have a very low privilege. It can't even make any new commits back to the repo. It may be able to give a comment to the merge request, but that's about all it can do. It can't do any deploys. It has no access to anything else. So after the merge request is done, you want to go up the level to do your full build and do a publish to like a Nexus or Artifactory or a Docker repo. Then you bump up the privileges a little bit just to perform those specific tasks to do the publish. Now, when you go up to the next level and do the deployment, it's a whole set of different privileges. So the privileges for your deployment can't push anything to the repo, but it can read from it. So that's where you get into this whole least privileges. Like I said, it can be a headache, but it does definitely lock things down. Always assume that you're going to get a breach. And one of the things on this topic, it really gets to how can I recover from it? You know, what is my recovery path? There's some really good ways to do it. If you look at chaos theory for doing releases, is you assume that the thing's going to break in production, and we're going to skip doing a root cause analysis. Who loves root cause analysis? You remember those from back in the day? You got to go and spend 2 weeks researching why it happened, and you realize it was somebody's cat that did it, walked across the keyboard and did a release. You know, that type of thing is important, but realistically, how you recover from an outage is even more important. What was it, Cloudflare, what was it, last week? Got hit by, I think, 39 terabytes in 30 minutes as a denial of service attack, and they're able to stop it. I mean, that's an insane number, an insane amount of data being thrown at for a denial of service. 39 terabytes in 30 minutes going at Cloudflare. And they were able to recover from it and deal with it. So look at chaos theory. If you want somebody that does it really well, Netflix. I mean, since COVID, how often do you see your Netflix and you're doing the weird spinning thing? And they've solved that problem, you know, automatically. And they're pulling services in and out, and you don't even know it as part of your Netflix. Make sure you're doing analysis in real time. This is some of the runtime monitoring pieces like AWS Guard Duty. There's a couple others. AWS Config can get in there and look at some of the configuration settings of your EC2 and ECS instances, EKS as well. And then finally, we want to secure our supply chain. You know, we want to stop stuff from getting in there that can give us a headache down the road. And this is where I've lived for the last year, is working with this document, the 800-218. It's more, lately, they refer to it as the Secure Software Development Framework. So if you actually go and search on the NIST, look for the SSDF instead of 218. You'll have a better chance finding it. It has, between this one, so 218 is mainly focused on VMs and hardware, you know, hardware-based installations. And traditional apps. You know, what am I going to do with securing Oracle SAP? You know, what am I going to do with a Java, you know, Eclipse application? You know, these more traditional apps that we have to look at. The corresponding sister document to this, 800-190, and I forgot to add it in the slide, maybe I did here. 800-190 is specific to containers. So you have to look at both of them. There is overlap, you know, both of them talk about least privileges, you know, that type of thing. But look at both of them because they do have some new recommendations for securing containers that you may not have thought about for when you're dealing with regular applications. So for example, in Kubernetes, there's a setting for the default privileges called SEMCOMP, SEMCOMP, that give the kernel, the Kubernetes, a little bit extra bump in its privileges. Some of those you want to make sure are turned off. There's a default one, but people can mess with them. They think, oh, I need to add ptrace in order to do something, and you want to make sure those are turned off at that level. So look at both of them, and then there's also a couple out of CISA that they're a little more general, so they span 218 and 190. and kind of give you a summary. The one thing I like about 218 is it's really broken out well. So it has the 4 main categories: prepare your organization, protect your software, produce well-secured software, and then how you respond. The prepare your organization part of it may get into some policy. There's a couple of them have to deal with policies for your organization. You can go back out to NIST and CISA and find templates for those policies if you don't have one already, to give you a starting point. But for example, some of the policies that exist that you need are my developers trained in secure development practices? So it's one of those, you have to make sure the policy is going to point to where the training documentation is, how often the developers have to go through that course, that type of thing. So there's some policies out there that you should look at that level. The protect your software, the PS part of it, really gets down into your steps of your pipeline. You know, how do I, like I was talking about earlier, ephemeral runners, signing, verification of the signing, how do I consume third-party libraries? Am I going to have a whitelist? Am I just going to block everything in the world? All that goes into play in the PS section. And it spills over into the PW section. The PW section gets into vulnerability scanning and what are we looking for vulnerabilities. And then finally, how you respond. It's great that we find these things, you know, and you're going to get overwhelmed, especially when you're looking at when you do your vulnerability scan and all of a sudden you're picking up, you know, 200 low and medium vulnerabilities. That points back up to your initial policy of saying our organization's only going to be worried about high and critical. High and critical have to be fixed within, you know, give it a time frame, a week, you know, or we have to have a 0-day mitigation in place to get around that at that point. Also, the policies and the response are going to have ways to deal with exceptions. So you're going to have to document your exception process as well. So an easy out usually is, well, we're on the high side. We're not connected to the internet, so we're never going to be exposed to this. So we're going to make an exception. And that may be your out for the short term, but you really have to go ahead and have a proper response protocol at that level. So when we look at this, what we want to do is really plan out what we're going to do. And this guide here, so I would say start with the 218 because it's laid out better than the 190. In each one of these, there's going to be a set of tasks. So like in the PO, there's like categories 1 through 3, I think. And then underneath, it'll be like PO 1.1, 1.2, 1.3, and then 2.1, et cetera. And so there's a handful in each one of those. It's broken out really well. It does come in JSON format, so you can actually bring it in and use it in reporting. The 190 is only, I think, a PDF. So I actually had to convert the PDF to a markdown, the markdown to JSON to get me a mirroring copy of the tasks in a JSON format so I could do my reporting. So start with 218. It gives you a better flow. Also for each task, it'll give you an example. And there'll be maybe from 2 to 6 examples, or maybe even up to 8, of what they're looking for you to implement for that particular task. What we did was you'd have 8 examples, and we would pick the ones that mostly applied to our use case. So some of them were pretty, didn't fall into what we needed to do, was like, having a hardware token for every GitLab runner, yeah, it's just not going to happen. You know, it's just one of those things that we just didn't have time to deal with and put in place. So instead, we use the software token for those instead of a hardware one, and that fulfilled the example. So start with 218, and then you're going to have to look at, based on that, what you need to start putting in place. You know, how are we going to look at separation of duties, least privileges, ephemeral runners, what is going to be the network segmentation. So what we did at Atlanta was we ran all of the commercial green side is on just plain old generic AWS. The yellow side and higher is up on AWS GovCloud. So there's that network separation right there. And then within each, on the commercial side, within each one, they separated it out by accounts. So my account for my project team is not shared by another account for another project team. So they separated it that way, so you had a little more boundaries in place at that level. Also to help track with their billing, they have the multiple accounts. And as part of that, even though we did have a shared Nexus repository, that was still controlled by the least privileges. So only the GitLab runners, one of them in particular, can push to it. So a developer can't sit at their desktop and push changes directly. It has to go through the pipeline process. And then finally, we want to continuously monitor your CVEs. Now, right here, it has an important part, post-deployment. So during your whole pipeline, you'll get your trivia, your SBOM, you generate your static code analysis, you get your vulnerability report, you go, great, I got 2 low CVEs I can just skip over for now. But after I deploy and it's running, how many do we get a day? 150. We got 3 critical vulnerabilities that are going to affect our runtime environment. So we got to continuously map up what's in running with the new CVEs that are being reported every day. If you don't, you're going to get caught sleeping. So, like I said, I'm a DevOps guy, so some of the tools that I would use, there's one called MegaLinter. It's a linting tool and a code formatter. There's another corresponding one called SuperLinter. MegaLinter I found is a little bit easier to plug and play into any pipeline. It will catch leak secrets, tokens that are being put into your Git repository. It will go and check to see if you have good coding standards. So like one of the famous ones I get caught by is in my Python code, I'll do a request to like go grab some data from a RESTful API endpoint, and I never put a timeout on there. So, and that's one of the best practices that the linter will catch. It's like, oh yeah, I should have a timeout after 5 minutes instead of never. You know, one of those best practices at that level. Also, the MegaLinter will look at Markdown code. It will look at Terraform. It'll look at anything you can imagine, Docker files, and give you a critique of what's happening in it and give you security guidelines at that level. Like for example, on a Docker file, making sure you're in your build, the last user that's stated is not root. You know, those basic little things, they're not hard to do, but you got to make sure that you check for them. Cosign is one of the other ones that it's very flexible. I like it as a replacement to OpenSSL. OpenSSL, you can do anything in the world with to generate keys and manipulate keys. Cosign is a simpler version, a lot of the same functionality, and it fits into the pipeline real easy. It can handle pulling keys from your KMS on the cloud side without bringing them into environment variables or on disk. So it gives you a really nice secure way to sign stuff. And it'll sign anything. If you have to do a file, a Docker image, attestation, any of that stuff can be signed by co-signed. And then what you end up having is a public key, or you go out to the basically the blockchain and do the verification that way. In Toto, it's a Python library, basically. It does have a command line, but I use it as a Python library. And I use it to create immutable log records. So every time we run a pipeline, we go and capture specific pieces of the pipeline to prove that we implemented all those NIST requirements. And we create an immutable version of that so we can generate our documentation. Trivy, SIFT, and Gripe, those three are dealing with generating your SBOMs and doing your vulnerability scan. And then Ortelius, which was, I had to put in there, I had to do a plug for my own project, is the dashboard that will oversee all this. So anybody ever look at a SBOM file? Yeah, pretty messy, isn't it? Especially SPDX. So I like using Cyclone just because it's easier for developers to read. But Ortelius can bring in SPDX or Cyclone. The vulnerability scan can run against SPDX or Cyclone. Just, there's some minor differences. There is some lost translation between the two, but they've been working that out over the last couple of years. So I really like, and these tools will generate either one. So this is what goes into your pipeline. So we talked about verify a lot. So up here in the top left, when you start the whole build process, you clone your repo, run megalinter, see if you're good on that front. You build your artifact, this artifact being a tar file, a Python package, a Docker image. It's just generic. Any of those you can sign. Then you run your SBOM against that. Trivy to generate the SBOM. You sign your SBOM. Then you verify your SBOM, and then you verify, you go and do the same thing for your vulnerabilities, and you sign your vulnerabilities, verify your vulnerabilities, you get the gist, sign, verify. And then what ends up happening is at the very end here, when you go to deploy, before you go to deploy, you make sure that nothing's been tampered with. So you rerun all your verification process before you actually do the install. So at this level, you're going to verify that your SBOMs are still valid, your vulnerability JSON is still valid, your artifact is still valid, and after that point, you got the thumbs up, you can install it. And then even as part of that, in the NIST 190, there's a monitoring section that you have to actually monitor that your image wasn't changed in your Docker container. So what we did was we created a Lambda that goes out once a day, dumps all of the running containers, and because we took the attestation and the signing inside of the Docker container, we can all pull that all out by the Lambda and verify it. And then we can kick out any images that aren't supposed to be there. So it's one of those things that you go through and you really start pulling all this together at that level. Let's see here. What do we have till 11:40? All right, we got 10 minutes. Some of the reasons why I've seen this process fail, especially if you're not mandated by the executive order, is there's no leadership buy-in, and there is a cost to it. You actually have to commit to doing this. Some of the other parts that are missing is you don't have any of the policies in place, and training is lacking. So you do definitely have to get those pieces rolling, and this has to come from upper management and their commitment. And then finally, some of the DevOps engineers don't want to change their pipeline. They're like, it's working. Don't break it. Don't touch it. It's very fragile, but don't break it. But you have to. You have to get underneath the hood, make these changes to keep it secure. Start with the high-risk pieces. So, and some of the high-risk pieces can have low-hanging fruit. So we've always said, take root access away from developers. Yeah, let's do that for production. That's low-hanging fruit that you can put in place at that level. Make it incremental. Just start getting SBOMs generated, then start signing them, then start testing them. Build upon it. Do it in an incremental process. Don't try to do the whole thing at once. If you're on the DoD side and you're dealing with containers, look to Iron Bank, Platform One, what is it, SpaceWorks? No, Space Camp is one of their other build engines. Iron Bank builds some perfect, really good Docker images for you to work from. And then see if you can get funding. My project was funded through the National Nuclear Security Agency to be implemented into LANL. So we got money from the NNSA to do a zero trust secure pipeline. So look outside your organization for funding. Just a quick summary. Let's go to questions since we got like 5 minutes left. And anybody, we do have a mic, or you could just shout, either way. Some remaining tools, since we don't have a lot of questions, or any, you guys. We want to keep, like I said, continuously monitoring this. The Ortelius project, that's one of its key goals, is to keep on monitoring what's happening post-deployment. Other tools that are here, the OpenSSF, the scorecard, Protobomb, Minder, OpenBio, those type of projects are coming out that are giving the tools to you to make things more secure, easier. So take a look at those. Yes?
I have a question about attestation for zero trust.
Yes.
How have you seen that done to date?
So I'll give you two different scenarios. So attestation of a Docker image is a lot easier than an attestation of we'll just say a tar file. So an attestation with a Docker image, this tool, Cosign, there's Cosign, and then there's another one I just came across called Crane, C-R-A-N-E, out of Conoco. Both those can take and attest your SBOM to your Docker image. It'll attest any file that you want, but we mainly attest our SBOM into a layer of the Docker image. And the reason why we do that is we can then pull that SBOM out of that layer without having to rescan the image. So it's already there, it's already been done. And as part of that process, you have to sign the attestation with a key. So that's how you do it for like a Docker image, is you actually take whatever you want to test, you push it to a layer in the image, and you have to sign that. And then you could verify that it was signed. And when you pull it out, that attestation, you can run another verification that it wasn't messed with at that level. So that's a Docker. For regular files, your attestation is in a separate file, and you still sign that attestation. And what ends up happening is you get your, let's say it's a JSON file you're testing, like your SBOM file is a JSON file. You end up with a .sig file, and that's where I use the in toto to create an immutable record of those files. It actually ends up being a set of files that is signed again to make sure that none of those files that I'm packaging together have been messed with. So it's a little trickier when you're dealing with just files, but the Docker OCI layers work really well if you can go that route. Does that help?
Yeah, it does.
So it's going to be a combination of tools. It's not going to be a simple one command. There are things that try to do one command, but I found that they're just not flexible enough. So you end up doing the multiple steps to get it the way you want it to. Any other questions? Yep, back there.
So you say it says over 100 days to remedy these vulnerabilities, and typically in government our releases months long. What's something like the first step that we can take in order to remedy these a lot sooner?
So the big thing is to figure out which ones are critical. So if you have the general policies I've seen are you have to deal with high and critical vulnerabilities. And then you're gonna have to set up your pipeline, your Git branching methodology to be able to bypass the current work the developers are working on for the last 2 months and be able to have a path to just fix those vulnerabilities and get them out there within a couple days. So it's going to be some developer work for them to understand that we can't wait 3 months, that we have to have a short path to this. On the mainframe, we used to call it an emergency fix. And it would bypass all of the changes, all the steps, and we could go right from our fix into an emergency runtime library. And then what ends up happening is that ends up on a branch, and then you circle those fixes back to the developers when you can. Anything else? Looks like we're out of time. I'll be hanging out for a little bit, so if anybody has any questions, just stop by. Thank you so much. These slides, I updated them, but I will push them up to Sketch, and you can pull them off. Just give me a little bit. And all these are links to the real websites for you, so you don't have to go hunt them down. Thank you, everybody.